This conference will now be recorded.
Okay, so good morning all and welcome back to the session. This is Big Data Masters program. In the previous session, what we have seen, we have gone through with basics like if we need to increase the availability of Hadoop cluster, what are the different strategy that we need to opt on. So we have gone through with high availability concept. Let me mention, recap to the previous session. So we have gone through with high availability concept. There we have seen checkpointing, quorum of journal manager, and addition of certain external hard drive in order to keep the data so that the system will be fault tolerant. If there is any issue inside the node or name node, whatever, so we will be able to recover the information. So we have gone through with checkpointing and quorum of general manager and attaching external drive. That was fine. Apart from this, what we have seen the concept of rack awareness. Rack awareness. So the main agenda over here, uh, like we are having multiple nodes and we need to replicate our data. We are having multiple replicas of our data and we need to put those replicas inside different nodes. It will depends upon the replication factor, and what I have mentioned, default replication factor inside the Hadoop is 3. However, we will be able to increase or decrease the replication factor for the data which is having or which is like having highest demand, or certain data that is having certain security and like what we don't want to be deleted, to be removed. So we want to keep that particular data into multiple nodes, and the data which is least required, we just decrease the replication factor over there. But the main agenda is how to keep that particular data, how to keep the replicas of our data into different nodes. And what we have seen, the best way to keep the replicas, that is to replica in one rack and another replica in second rack, or third replica, what I can say, and third replica in second rack, or another rack, what I can say, another rack. So it will give us the benefit, like the latency related challenges will be you can say overcome over here, and we will be able to fetch the data if a node is down within a particular rack, and if a rack is down, then we will be able to restore the data from the another rack. That is like to increase the fault tolerant capability in the Hadoop ecosystem. So we have seen these particular concept. Then we have seen how to how to set up the environment. Set up the environment. So for this, I have shared certain files, and based upon those particular files, probably all of you are able to set the environment. I just want to take a feedback from all of you. Uh, were you able to download Cloudera Quick Start VM and uh, import it inside the quick virtual box? Rohit, Pankaj, Gaurav,
Yes,
Vikas,
Ashok.
and Rahul.
Yeah, Ashok.
Yes,
Yeah,
Ashok.
Ashok. Yeah,
I
Ashok.
was able to do that.
Okay. Anybody facing any challenge in order to import?
No, no, import is done successfully. So just want to confirm like the virtual setting of the setting of virtual machine, how to make like to increase the RAM and all in the virtual.
Okay. So
Yeah,
import
just
is
want.
not done
Yeah.
yet, huh?
No, no,
Okay.
import is done
So
successfully. Like
import or
in
download,
the
huh? So,
yeah, yeah.
hmm.
So
Okay,
in
while
my
importing,
system,
you need to set up. While importing,
yeah,
you
yeah,
need to
yeah.
set up.
Yes, yes, yes,
Okay.
exactly.
So probably all of you are able to see Cloudera Quick Start VM in VirtualBox. It will look like this, huh? Cloudera Quick Start VM 5.13.0 hyphen o, VirtualBox. So if you are able to see, that is fine, huh? Although like you will be able to uh, change the configuration, huh? So let me start it for you. Okay, and let me start Cloudera Quick Start VM. So you just need to see over here. Probably by
Uh,
default the RAM is 4 GB.
Actually, my base memory is showing by default it's 4 GB. So I just want to
Yes.
increase
By
it.
default it
Yeah,
will be 4 GB. You need to increase it to up 8 GB, 800 MB. Okay.
yeah. I tried, but it goes maximum 7 GB, not goes for complete 8. I don't know.
Probably your laptop is having 8 GB configuration,
Yes,
right?
yes, right, right, right.
Yes, that's fine. So 4 GB is fine. Now, if you are having 8 GB in your
Hmm.
laptop, then 4 GB is fine. But recommended is 8 GB for the virtual box in order to work with Cloudera Quick Start VM. You will be facing latency related challenges. Okay.
Okay,
So you just need to, all of you, you just need to start and the screen, the very first screen that you will be able to see, it will look like this, Cloudera. Okay. Okay. So you need to try like starting the Cloudera Quick Start VM. And once you are able to start the screen that you will be able to see, it will look like this. Okay. So this is the Cloudera prompt, and this is like having the tools which we are requiring in order to work with Hadoop. Just have a look over here. Hmm, Let me open the browser. Okay, and over here, just have a look Hadoop, HBase, Impala. Inside Hadoop, just have a look. Name node is there, secondary name node, data node, resource manager, node manager. Okay, we have seen these particular things: name node, secondary node, resource manager. Yesterday we have discussed a lot about resource manager, node manager. These are nothing but running onto the data nodes. Okay, and these particular things came inside the Hadoop 2. Okay, this is with respect to the Hadoop version 2. So these are the things which we are requiring in order to deep dive in our journey with big data, and we will be working. We will be having data. We will be storing and processing data over here in order to learn our big data journey. Now, once we are having Cloudera Quick Start VM, then there are certain things that we are going to cover in our today's session. Okay. So first of all, let me walk you through with the basics. Like with what are the different things inside the Hadoop ecosystem? What are the different configuration files and all, and how we will be able to access Hadoop. So once we are working with Hadoop, Then there are three types of modes. The first topic what we are going to cover, modes in Hadoop. Modes in Hadoop, like you, what are the different ways in which we will be able to work with Hadoop. So there are different modes. So first one is standalone mode. Standalone mode. So over here we will be having a single machine. The Hadoop is deployed on a single machine only, and distributed processing is not happening over here. It is it will be having, it is going to use the local storage. Let me mention over here for you. So here Hadoop is deployed on single machine, and distributed processing is not happening over here. Okay, we are not having the benefit of distributed processing, and local storage is being used. Is being used. So the main motto of Hadoop ecosystem is to have the distributed processing. Like until unless we are not able to process our data with multiple nodes, then we will not be able to improve latency. If single machine is working, then that will be the monolithic way of working, monolithic way of processing. Monolithic way means one single machine is going to process our data. So this particular mode is for test purpose only. This is used for testing purpose only. Okay, so we are not using this particular mode, and this is not, you can say, preferred as well, because distributed processing is not happening over here. The second mode what we are having, that is pseudo random mode, pseudo distributed mode. Pseudo distributed mode. Over here as well, we are working on single machine, but we are having the benefit of distributed processing. Let me copy and paste it over here. Here Hadoop is deployed on single machine, and distributed processing is happening over here. Let me rub the note. So that means this is a good way to process. But like if we are having single machine, just try to focus over here, guys. Okay, uh what actually big data is, uh like once we are having huge amount of data which is not processed by a machine, like in another word, say I'm having this particular machine that is having 512 GB of disk, and if I'm having the data of 5 TB, that means my machine, my laptop is not able to handle or store or process that particular 5 TB of data. It means this is beyond the capacity of my machine, right? So what I need to do, I need to add more machine. Same thing is happening over here. Like Hadoop is deployed once the machines are not able to handle the data. Once a machine is not able to handle the data, so we are adding more machines. Okay, we are adding more machines so that we will be able to process that huge amount of data which is beyond the capacity of a particular machine, single node or monolithic machine. Okay, so over here Hadoop is deployed on single machine. It is able to do the distributed processing, but this is also not a preferred mode. It is good for learning perspective. This is this is not, this is also not a preferred mode of working. It is good for learning perspective. It is good for learning journey perspective. Okay, it means so what we have done over here, we have deployed Hadoop on this particular machine. It is able to do the distributed processing. Okay, so this deployment is pseudo distributed deployment. So what we have done in our machine, we will be having multiple nodes. Okay, we will be having multiple nodes, but multiple data nodes, but those particular nodes will be available virtually. Try to focus over here. Here the Hadoop is deployed on single machine. Virtually we will be having multiple nodes, but all of those particular data nodes, virtual data nodes, are deployed on single machine only. We will be having name node, we will be having data nodes, but those particular data nodes are available within this particular machine, a single node. So my machine is having multiple virtual machines, so that is good for learning. You will be having the actual environment, like you will be having a feel of like actual environment, and you will be able to grasp the content, like what actually is happening inside once we are having a big cluster. So we will be able to take a feel, but this is not the production ready deployment. It is not like the products or the software what we are going to have, that is going to consume huge amount of data. Those particular products are not having this particular configuration, like it is not preferred to deploy Hadoop on a single node. So this environment whatever we have said, that is good for the learning perspective, but it is not a production ready environment. We are not deploying it inside the production, okay. So this is nothing but the pseudo distributed mode. This is the mode where we will be working. This is not the preferred mode, where like we are not having the benefit of distributed processing. Each and everything is available over here, like distributed processing and distributed storage, but those particular things are available in single node only. Okay, single machine only. Okay, in this particular laptop only. And third one is fully distributed mode. Okay, so fully distributed mode. Over here, this is the actual production environment. And we are having multiple machines over here. Over here, we can have certain examples, like in our learning journey, we will be going to create a cluster over EMR, over AWS basically. That will be EMR cluster, enhanced map reduce. We will be going to work. Okay, we will be going to create EMR cluster onto AWS, that will be having multiple nodes. We can it will depends upon us, like how many nodes we want to have in our cluster. Okay, how we can enable scaling, like if the data is increased, so how we will be able to increase nodes dynamically. So we will be able to see those particular configuration as well. So that particular mode is fully distributed mode. We will be having Databricks cluster as well. We will be learning Databricks as well. So over there as well, we will be having multiple nodes, and those particular nodes are working uh, in in or those particular nodes are forming cluster, and we are going to utilize that particular cluster in order to process and store our data. So these are the three different modes what we are having in the world of Hadoop in order to process our data, process and store our data. So just have a look onto these particular modes, and ask if you are having any doubt. All of you, just have a look. Is it clear?
Ashok?
Yes,
Yes,
please.
Ashok.
In pseudo distributed mode, we have deployed Hadoop in one single machine. Then how distributed processing will happen? Uh, I'm not able to understand. Can you please explain?
Actually, this is single node cluster. It will be single node Hadoop cluster. So what will happen? Yesterday we have seen seen the containers. Okay. So
Okay, okay,
what
understood.
actually? Okay. So you
Hmm.
will be having the feel like from a particular machine you will be able to create different nodes. Those will be the virtual nodes. What I have mentioned. Right.
Understood, understood,
Okay.
understood.
So with the help of containers, you will be able to see.
Take the feel of distributed
Yeah,
processing.
and this is nothing but the virtualization.
Hmm.
Virtualization. And whatever you are able to see, this is the virtual box. And like in a particular machine, we can have single operating system. Okay, we can have single operating system, but with the help of virtualization, this particular physical machine is working as two logical machines, two virtual machines. One is having Windows operating system, and another one is having Linux operating system. So we will be going to write the Linux commands over here. Just have a look. Okay, see ls. So it is going to list. Okay, these are ls is the command from Linux. Okay, so what I have mentioned, we are having three types of modes in Hadoop ecosystem. Okay, inside once we are working with Hadoop, we can either work in any one of these particular mode, and fully distributed mode, that is the preferred one. And over here we will be utilizing, with respect to our learning journey, that will be pseudo distributed mode. However, we will be going through with fully distributed mode as well once we will be working with EMR, that is enhanced map reduce, that is a service from AWS. uh, During the sessions only, we will be going to create EMR cluster, and we will be able to see like the data nodes, name nodes, and all of the required stuff we will be able to see. Okay. uh, that is with respect to modes. Now we are having certain files. Based upon those particular files, we will be able to configure Hadoop. Like there are certain configuration files which we need to see. Sometimes like there are certain issues, and we need to find out reason, like what exactly is happening in the Hadoop cluster, and we need to resolve those particular issues. So we need to have the understanding about those particular configurations which are there inside the Hadoop ecosystem. So Hadoop ecosystem is having five main files. First one is configuration files. Files in Hadoop ecosystem. First one is core site.xml. So this particular file is having cluster information, storage information. It is having cluster information like cluster ID and storage information. Let me show you this particular file now. Okay, so inside, what you need to do, you just need to go to the my computer. Then we are having the file system over here, uh, etc. Hadoop. Okay, and conf, and over here, so core hyphen site.xml. Let me open this particular file. Okay, so just have a look the content of this particular file. This is the XML file, and what I mentioned, it is having the cluster configuration storage information. So uh, configuration property, fs image, that is file system default, quick start. This is the value, like the Cloudera quick start is running onto this particular I port 8020, and Uzi. Okay, we are having Uzi, the configuration which are required. And then what we are having the second file. So that is hdfs hyphen site.xml. So it is having the information like replication factor, replication factor, and a block size, location where data is stored, hdfs location of hdfs store.
But
Just
Ashok,
have
block
Mhm.
size is fixed, na?
uh, block size is fixed, but in certain scenarios you will be able to change. You will be able to change.
Okay, we can
Nothing is
change
fixed.
from either
Default
if
is
Hadoop
128.
tree.
Default is
Yes, yes.
128. Default is 128.
Okay, okay.
Okay, just have a look. HDFS site.xml. This is the file. So even like default replication factor is 3, but over here just have a look. The replication factor DFS replication factor 1. Right, we will be talking on to this as well. Default replication factor. Okay, so that is one. Then safe node minimum data node. If you are moving in the safe node, how many data nodes you want to have? One. Permission, DFS permission enabled. Okay, so that is set to false. And minimum data node, then temporary directory, what we have mentioned, like the storage directory, the Hadoop storage directory, so that is mentioned over here. Then name node directory, this is the name node directory. Okay, checkpointing directory, just have a look. Yesterday we have discussed a lot about the checkpointing, right? So inside the Hadoop hyphen site.xml, we are having the information of the checkpointing directory, right? Are you able to see, all of you? Quick confirmation.
Yes, yes. So
Yes, yes, yes.
Yes.
Perfect. So those particular configurations, like whatever we have discussed, that you will be able to see over here. So RPC, that is remote procedure call bind, that is a, you can say, protocol. And address and name node address, data node address. Okay, so just have a look. Once we are clicking onto the name node, just have a look over here, name node. I'm clicking HDFS name node, and it is binding to 50070. That is the port number, 50070. So it is bind over here, 50070 name node HTTP. Are you able to see? So it is like connecting to this particular port once we are opening name node. Like once we are interacting name node, then we are interacting with 50070 port, because onto this particular port the name node service has been deployed. Once we are like clicking onto the data node, then 50010 port will come into the picture. So data node, 50075. Okay, 50075. Okay, so 50075. So one thing is there, like based upon the data nodes what we are having. Just have a look over here. DFS data node 50075, HTTP address 50475. Whatever that is coming over here, that is based upon the configuration which we have set inside our configuration files. Okay, so we have mentioned it somewhere because of that particular region, it is pointing to that particular port, right? So we are able to see, okay, because we have configured over here. Then certain impala configuration, that is with respect to a tool, like what are the things with respect to the impala. So over here I have opened hue. Okay, huh I have opened hue. Let me open it once again. Just have a look over here. Okay, so I have opened hue, and inside the hue, that is Hadoop user environment. And what we are able to see, impala. So impala is nothing but like over here we will be able to write SQL like commands in order to process our data, in order to do the analysis on our data. We are having two query editor, that is impala and hive. So impala and hive. So it will be like we will be moving in detail with hive, but impala is also there, which is having almost the same coding methodology, or it is going to use the commands, SQL commands, SQL like commands, not exactly SQL. It is going to utilize the SQL like commands, which uh, with the help of that we will be able to do the analysis. So over here impala is there. Now these particular configurations what we are able to see over here, that is with respect to the impala. Okay, so we have set the impala configurations, like on which node, uh, where we are going to have the metadata. If like certain limitation is there, then what will be the timeout. Okay, so these are certain configuration, although like there is no need to bother about these particular configuration what I have mentioned. The admin guys are going to look based upon the cluster where they are going to install these particular applications, so that you will have the smooth functionality. Okay, but we need to have understanding. So whatever we are able to see, that is with respect to the configurations what this sdfs-site.xml is having, and those particular configurations are required in order to have the smooth functionality. Okay, so this is the second file, sdfs-site.xml, and with the help of this we will be able to see different information like block size, location of sdfs store, impala configuration, and where these particular files are located. These particular files are located inside the file system. In file system we having etc directory, and etc is having Hadoop directory. Inside the Hadoop conf file we are having all of these particular files. Okay, then the third file, what we are having, uh, third file. So the third file we are having mapred hyphen site.xml. Before moving with this particular file, uh, let me try to explain. So we have seen Hadoop, and Hadoop is having two main components. That is, one is HDFS, and second one is MapReduce. MapReduce. Okay. HDFS, that is Hadoop Distributed File System. MapReduce, that is the combination of mapper and reducer. We will be discussing in detail about both of these two words, but what exactly is happening in the world of Hadoop? Uh, this particular component, HDFS, is responsible for storage, and the MapReduce, this particular word or component, is responsible for processing up. And try to recall what we have seen in our first session, where we have discussed a lot based upon the storage and processing only. Like, there are two challenges once we are dealing with huge amount of data. First one is storage, like where to store, how to store. So storage, so Hadoop has given a solution, like in order to store the data we are having SDFS, and that is nothing but distributed way of storing the data. Then the second challenge what we are having with huge amount of data, that is processing. Until unless we are not processing our data, that is not making any sense. Processed data will provide you certain information, and that particular information uh, will be applied in order to boost the revenue, in order to enhance the functionality of a particular system. Okay. Until unless we are not able to process the data, we are not getting anything. So processing is mandatory, and MapReduce is the processing component. So whatever you are able to see HDFS site.xml, that is with respect to the storage. Okay. And what you are able to see over here, MapRed site.xml, that is with respect to the processing. So once we are having processing, okay, then like it is having certain properties, say execution mode, execution mode, and uh, other properties like number of reduced task per node, number of map task per node. Okay. So what is the meaning of reduced task and map task? Now I'm moving a little bit in a little bit more detail. Map reduce, what I mentioned, mapper. This is the combination of two words, mapper and reducer. Reducer. We are talking about map reduce. MapReduce. So the content of the mapred-site.xml is with respect to the map plus reduce, mapper plus reducer. So say we are having five machines, say machine one, or let me call node, that is looking good. Okay, say we are having these particular nodes, node 1, sorry, node 1, node 2, node 3, node 4, node 5. So we are having five nodes which are processing and storing my data. Now what we are going to have, say we are having a file, then file is given to and we want to store or process this particular file. So this particular file is having a very huge size, so the single machine was not able to handle, was not able to process. So I have deployed a cluster onto 5 node, and then I will be utilizing to process and store this particular file now, say 10 TB file now. Okay. So this file is of 10 TB size. So what I will do, I will divide this particular data in terms of blocks, and these particular blocks are mapped. Try to focus over here, mapped onto these particular nodes. say we will be having 2 TB over here, 2 TB over here. So each and every node will be having 2 TB data. Okay, forgot about the replication and all at this moment. So each and every node is having 2 TB data. Now these particular nodes are working, say processing this particular data. Okay, so processing, and these particular nodes, all of these nodes are going to provide intermediate output. Let me mention over here, intermediate output. Intermediate output. This is not the final output, we know it very well, because like I just want to process this particular file, I want to process the entire file. I don't want to like get the output from node 1 which is having just 2 TB of data. I want to have the outcome based upon the entire data that is of 10 TB size. So I will be having intermediate output, and this particular output will be given to another node, or I am going to, it is going to decide, like Hadoop is going to decide like which node it is going to utilize in order to provide the intermediate output. And then this particular intermediate output is given, all of these particular machines are going to give the intermediate output to another node, and that is called say reducer. And from the reducer, what I will be getting, that will be the final output. Okay, so what we are able to see, the data is mapped in multiple machine, and then further the reducer is utilized in order to provide you the final output. Intermediate output is processed by reducer, so that you will be having the final output. So the map reduce file is having this particular information, like how many mappers we can have in a node, how many reducer we can have, how many like reduced tasks we can have, how many reducers we can have. Okay, it might be possible the data size is very big, and like intermediate data is very big, and the single reducer is not able to handle that. Then what we need to do, we need to add more reducers. Okay, more reducers, and like that will be uh, again like we will be having a chaining mechanism, and then finally we will be able to get the output. We will be learning certain other aspect like how to reduce the load of reducer, how to improve the functionality of reducer, because over here this is working in a monolithic way, and distributed processing is happening over here. So we will be going in detail with those aspects, but to give you a flavor like what exactly is there in mapred-site.xml. So this is with respect to basics. So mapred file is having these particular details about this particular flow. And over here inside the etc Hadoop path, we will be able to see mapred-site.xml. So just have a look. What we are having, job tracker, job tracker information, job history. Okay, how the processing is being done, task tracker, are we having task tracker related stuff, the map reduce tasks temporary directory where the intermediate result will go from, because like we are going to provide, what we are going to provide, we are going to provide this is the input, and I want the output over here, but where this intermediate result will be stored, so that will be stored in this particular directory, and reducer is having this the information like I will be having intermediate result over here, so job history, so these are like the information what we are having inside the mapred-site.xml. Now, one thing I forgot to
Uh,
explain.
Asok, for the same
Mhm.
file where we can see the output, like uh, the XML file you showed, na? Uh,
I have not shown the path of this particular file. Okay, file is there, how the execution will happen? Say execute, execute. I'm writing in a hypothetical way. This is the not the exact command. So execute, say file, this particular file, execute file. This particular file is there. Say batch, say 32, and execute batch 32, and file say 1. Okay, this is the say directory where this particular file is available, and what I want to have, I want to have the output, say batch 32 output. Okay, and in this particular directory, so what I'm going to do, I'm going to create a directory, say mkdir, and sorry, it is in bin now. Okay, Hadoop version will work at this moment. So we were on different directory. Okay, just I saw this bin. Okay, so like mkdir, and say batch, batch 32. Okay, so permission denied. Okay, so just have a look. Batch 32 is created. Inside this batch 32, say I am having certain file, and I'm going to execute that particular file, and I want to keep the data in this particular path, batch 32, and I am going to create another directory that is name with name output, and over here I will be able to get the outcome. So this is say on, this is an example how I'm going to execute a particular file, but exactly like what is happening, say it is going to map this particular file among the available cluster, and then intermediate output is stored in the intermediate path which is mentioned in this particular file, say. Okay, a configuration file, and from there the reducer is going to take, and finally I will be having the output in batch 32 of output directory, right? So I'm not mentioning uh, the path of temporary file, temporary path, like where intermediate output is stored. This is the the content of configurations, right? Is it fine?
Yeah, yeah, fine,
Mm,
fine.
Ashok, one more
Mm-hmm.
question. Like if
Mm-hmm.
the size of the intermediate outputs are very high, so that
Mm-hmm.
we require more than one reducer to get final output, then how it will
Mm-hmm.
work?
Actually, the thing is that if the size of the intermediate file is big, okay, reducer, we are going to mention like how many reducers are there. We are going to write down in the code. Okay, we need to mention these particular things in that inside the code, like say I need to have one reducer, I need to have two reducer. If like you are mentioning, say you are moving with single reducer, by default like there will be single reducer, okay. If you are observing latency related challenges, then you need to increase the reducers, okay. And reducer, like if you are having one reducer, so you will be having one file in the output. If you are having two reducer, then you will be having two reduced file. That will be, the output will be given in two files, right? Further, if you want to process that particular, then again you need to move with processing, and that will be given in two files. Now, if you want to have the data in single file, so what you need to do, you need to have one reducer only, and the data what it is going to process, it is going to process with huge latency, if the data size is big. Either you need to increase the capacity of reducer, okay, or you need to you need to be happy with the outcome that will be given in two files,
Means is there way to merge those two final outputs? Like if we have two reducers and we
you
got
need to
two
you
final
need to
outputs.
you need to mention in the logic, okay. Say if you are working with five reducers, say you are having very huge clusters, say you are having 400 node cluster and five reducers are there, so you whatever we are going to do, say if we are having mapper, if we are having reducer, we need to write down the logic, like how the data is being processed over here, okay. If we want to move more data towards the reducer, so that means the functionality, the coding mechanism is not good, what we want, we need to do the maximum processing over here, and the result, okay, which is moving to the reducer, that must be very less, if it is more, if you are deploying more reducers, then what you need to do, if you are having two reducer, you need to write down the logic in such a way that uh, like you will be able to get the final output, right? Each and everything will be depending upon the logic, definitely there is a way, but that is with logic only, merging the output, over here
Okay.
we are having another component of partitioner, okay. Partitioner, it is the person who is going to decide which data is moving to which reducer. We need to write down the code for partitioner as well, right?
Okay.
Okay, we are having another component combiner, that is having the same logic combiner. It is not our telecom combiner, okay. So combiner is doing what? It is working in such a way so that reducer load will be less, so it is reducing the load of reducer. Combiner is working, it is having the same logic which is there inside the reducer. We will see through practical, we will be having certain Java code, so with Java code we will be able to get the functionality how these particular things are working, so combiner is going to offload reducer, and how you can think in this particular way, like if you are resigning, then someone will be there who is going to take the responsibility of yours, so that or say you are having very high load, you are doing a lot of work, then you want a person who can offload you, so how that person will be able to offload you once he is going to do the task what is being done by you, so reducer logic is replicated over here, and it is working in the same way how the reducer is working, and the main idea is to increase the distributed processing or parallelism over here, these particular machines are working with parallelism, and it is not having the benefit of parallelism. We will be having detailed discussion on to this, okay. So so we are adding combiner to reduce the load of reducer, right? And partitioner which is deciding which data is moving to which reducer, right? To answer the Pankaj your question, partitioner is there which is deciding which data is moving to which reducer. With the help of this, you will be able to manage Like I just want to have more data towards the reducer one, which is having the good configuration. I just want to have less data, which is having to reducer two, which is having less configuration. Those particular things are pretty possible, right?
Yeah, okay, got it.
Okay, one thing, anyone having any doubt up to so far? Any doubt, any confusion?
Ashok, one thing, this job tracker will be part of NN or DN
Job tracker is the part of name node.
name node only. Fine, fine.
Hmm.
That's it. Thank you.
Okay. So job tracker is nothing but monitor and scheduler. And this job tracker is available, say in Hadoop 1. In Hadoop 2, what we are having resource manager and node manager related stuff. Right?
Okay, okay.
Okay. So resource manager, that is scheduling, and node manager, inside node manager one, another component we are going to initiate, that is application master, which is going to monitor the application, right? So what I have mentioned, I forgot to explain one thing inside the hdfs site.xml. We have seen replication over there, replication and default replication inside Hadoop, in default replication. Default replication was one over there. Let me show you once again. Okay, sdfs site.xml site.xml, and over here we are having one word, that is replication. Okay, default replication, that is one. Okay, so I have mentioned, like inside the Hadoop we are having default replication 3, but in our pseudo distributed mode default replication is 1. Why? Can anybody tell me why replication factor is set to 1 over there?
Only a single node is we are using. I
Hmm.
think that's why.
Mm-hmm. Anyone else? Why replication factor is set to 1? Are you agree with Pankaj? What Pankaj mentioned? Are you agree with that?
Yeah, we are having one node only.
Because we are using virtual machines on a single node, na?
Yes.
So if having any issue with the node, then all the virtual, you can say,
That is fine, perfect.
yeah,
So,
yeah, yeah.
what exactly is happening in the world of Hadoop? We are having, say, storage and the processing related stuff. But over here, what we have done, we have deployed the cluster on single machine, and replication is utilized for what? Utilized for fault tolerant. Fault tolerance perspective, we are having this particular word replication. Like if a data node or name node is down, if a node is down, let me be more specific. If a data node is down, then we will be able to recover the information from another node. But we are over here, we are running with single node only, and if we are keeping three replicas in single node, it is not making any sense. We are killing the resources of our machine. Okay, in single node only we will be having three replicas of single file. Okay, it is going to occupy more storage, right? So
There is no meaning to have more replica in
yeah, there
single
is
node.
no use to have three replicas in single machine. So that's why, like, replication factor in our pseudo distributed mode is set to 1. Okay, perfect. I'm fine so far. Then moving further, what we are having another file yarn-site.xml. Yarn, that is yet another resource navigator, and this is nothing but the resource manager. Okay, fourth. So this is resource manager, and it will be having resource manager, node manager, and AM, application master related configuration. Let me show you this particular file. Okay, yarn-site.xml. Okay, so just have a look over here. Node manager services, yarn log aggregation enable, and list of directory to stored localized file, node manager local directories. Okay, yarn node manager local directory, location directory, then certain values, SDFS home, MapReduce home, yarn home. These are certain configuration. Class path for typical application. Okay, so node manager, resource manager related stuff, what we will be able to have inside the yarn-site.xml. These are nothing but the configuration files. With the name itself, we are having an idea that this particular file is having resource manager related stuff. Okay, so that is there inside the yarn-site.xml. Close without saving. I don't want to save. Okay, so we are having Hadoop environment log4j. We have gone through with these particular files. We are having some another files. Let me check. Hive configuration. Hmm. So hbase-site.xml, not hive. hbase-site.xml. Hmm. 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 So hbase, like I just want to show you one diagram first, then we will move with the content. Okay, so just have a look onto this Hadoop ecosystem. This is the diagram of Hadoop ecosystem. So inside this Hadoop ecosystem, we are able to see different components. Like this is one component, this is another component. We are having one component, another component. So we are having different components. What we are able to see over here. So we will be going through with different tools. What we are able to see over here, like different tools are available. Say HBase is there. Uzi is there, Cloudera, Hue, we have opened Hue, Cloudera search is there. That is Hive and Impala. Inside Hue, what we have seen, Hive and Impala is there. We have seen HDFS MapReduce and HDFS. HDFS, that is distributed file system, and MapReduce, that is distributed processing mechanism. Yarn, we have seen, that is nothing but the cluster manager. Now, for HDFS, we are having HDFS-site.xml. For MapReduce, we are having MapRed-site.xml. Okay. Uh, for uh, for uh, for yarn, what we are having, yarn-site.xml, and SDFS, MapReduce, Yarn. For Core, that is like common to all. Core-site.xml, that is having common file. What we are able to see over here, we are having Hive. So we will be having Hive-site.xml. What we are having HBase. What we will be having, HBase-site.xml. Scoop hyphen site.xml, flume hyphen site.xml. So with respect to each and every tool, what we are able to see over here, we will be having different configuration files. Whatever we have seen, that is with respect to SDFS, Yarn, MapReduce. These are the like main things, and core, that is common to all. Now the remaining tools, like if the Hive need to interact uh, with storage and processing, then we need to have certain configurations. If HBase and HBase need to communicate with Hadoop, that is HDFS plus MapReduce, then we need to have HBase-site.xml. So we are having like different functionalities. What we are able to see over here, we are having different tools. Each and every tool is having different functionality. For each and every tool, we will be having different configuration file. So HBase-site.xml is that is required in order to interact with HBase. Like fifth one is, say, HBase hyphen site.xml. Site.xml. Now you need to understand what is HBase. Now HBase is nothing but a NoSQL database. Over here, a very special word that is mentioned, that is NoSQL. NoSQL. That is not only SQL. Okay, that is, it is a NoSQL database. So once the data is stored inside the HDFS, that is Hadoop distributed file system, and if we want to query onto that particular data, then we are going through with HBase. We will be going through with this particular database, like how it is working, how to interact, how to integrate it with Hive and all. So we will be going through with that particular content or concepts. But HBase is a tool which is utilized in order to query the data which is stored inside the HDFS. In the same fashion, what we are having Hive. Hive is a tool, that is data analysis tool, and it is utilized once we are having data stored inside the HDFS for the analysis perspective. Same Impala is there. So the special files what we are having, or I can like divide it into HBase-site.xml and say uh, Hive-site.xml. These are the another files, and these files are having the configurations with respect to having the interaction with HDFS, the data stored inside the HDFS. So just have a look onto the HBase-site.xml. So on which port it is running. Okay, the HBase distributed cluster distributed ID, the path uh, where the temporary directory or path and all Okay, so type text as the configuration and xls. So like the configurations which are required on this particular pod it will run, and it is having certain configurations. Then okay, region server. So region servers are there inside, like HBase is also master and slave architecture, and it is having one master and different region server. So region server IPC address, that is nothing but say data node ID. So these are the region server ID, and each and every, this is master IPC address and region server master. That is like that is one who is going to control the HBase cluster, and HBase region server, that is like similar to data node, which we are having. So we will be going in detail with respect to the architecture and all. Okay, so HBase architecture especially, so over there we will be able to see like what is region server master ID and all. So root directory, where like the data from where we will be able to from where we will be able to store the data and all. So that is nothing but hbase hyphen site.xml. In the same fashion, what we are having hive hyphen site.xml. Hive. So hive is also having hive hyphen site.xml. And so that will be having the configuration in order to do the analysis onto the data which is stored inside the SDFS. For each and every tool, we will be having the configuration. Say Impala. So conf Impala hive also hive settings are replicated over here. This is the okay. We are having almost this all the files. Hive hyphen site.xml, yarn hyphen site.xml. So hive and Impala, these particular tools, these are almost similar tools. Probably because of that particular reason, like hive hyphen site.xml configurations are replicated over here. Then say other tools, say pig. Let me check for the pig. Scoop is there. Say scoop. For scoop, like we are having scoop hyphen site.xml. So that is the configuration which are required in order to have the interaction uh, of scoop with HDFS. And Spark, for Spark is there. Spark hyphen site.xml. No. Okay, fair scheduler.xml. So this is scheduler related configuration. Spark environment.sh. These are the configuration files over here. It is running. Actually, like Spark is running on top of Hadoop. Just have a look over here. So just have a look over here. I have mentioned Spark. So it is running on top of Hadoop. It is not like it is going to have its own configuration or environment variables. So probably those those hyphen site XML files are not required over here. So the main agenda why I have gone through with these particular files, that is to provide you a feel like what are the different configurations we can have inside the Hadoop, and like how we will be able to see the different parameters and what is the path of those particular files. Sometimes we may have a challenge, okay, and at that moment we will be able to recall and we will be able to to solve that particular issue. So these are different configuration files which are available inside the Hadoop ecosystem. Okay, moving further. So let me take a pause and ask if you are having any doubt. If you are having any doubt, please ask. All of you, all of you, if you are having any doubt, you can ask. So any issue, friends? Anything that you want to ask? Anything that is going above your head? Huh?
Sure. In
Mm-hmm.
summary, we can say that these are the part of the Hadoop ecosystem, and these are the configuration related files that we need to remember for time being, I think.
These are configurations only, and you from the developer side, developers perspective, you no need to bother about these particular configurations. Huh? We are having another team which is looking for these particular configurations and all. Huh? Okay,
Just we need to
so no need
understand this
to.
is a part of the Hadoop system, and this is a configuration file only.
Yes, yes, but this just I was trying to give you a feel like how uh, are the what are the different types of files available, huh? And like we have started our journey, so I just want to give you a flavor about these particular files, huh? Nothing else. Okay, so it is like a address, huh? An address. Say if you want to connect or like drivers related things, huh? In Windows, what we can say drivers, huh? Like if we need to install something, then we need to have drivers, huh? So in the Linux world, like we need to have configurations, huh? We need to set the configurations for a particular application tool, okay, whatever we are going to use, so that we will be having smooth functionality, right? So Hadoop is nothing but it is having two component only, storage and processing, but over here what we are having Hadoop ecosystem, and Hadoop ecosystem is the combination of multiple tools and technology. Okay, so what you are able to see, that is the Hadoop ecosystem. Okay, from the Hadoop perspective, like HDFS, Yarn, MapReduce, these are the component. But from the Hadoop ecosystem perspective, we are having Scoop, that is another tool. Flume, that is another tool. But it is going to interact with this Hadoop. So if it is going to interact, then we need to have certain mechanism with the help of what it will be able to interact. So we are having configuration files. That is fine, with the help of configuration file. Now, whenever this particular environment is set, then you are going to work in this particular environment. But from the setting perspective, like what the admin guys has done for you, I was just giving a feel, right?
Right. So what is NoSQL?
NoSQL, that is a database, database.
How is it different from SQL? Not structured data.
Uh, yes. So NoSQL data, like we will be going in detail. Basically, inside the NoSQL, what we are having certain properties. Okay, ACID compliant. So the RDBMS or databases, SQL databases are ACID compliant. So we are having four main characteristics, that is atomicity, uh, consistency, isolation, and durability. So those particular things are compliant by SQL databases, but NoSQL databases are not complying as NoSQL databases are not ACID compliant, and the data is not mentioned, like it is not the way how the structured databases working are working. So we will be going in detail. First thing, like NoSQL databases are not ACID compliant. That is must in SQL databases. Another thing, the data which is mentioned over here, that is like it might be possible we are having columnar store, columnar storage. Inside the inside the ACID compliant databases, we are having data that is mentioned in raw format. like in one row we will be having data, okay, and then another row will come. So searching mechanism and all that is very tough over there, okay. So searching mechanism and all, like if the data is not in a structured format, then how to handle that particular stuff, if the data is there, that is having linkage, or the data is there in uh, in say we are having name, and name is further divided into two columns, so say first name and the surname, and then uh, like in the structured format, like we will be having name and surname. But if the data is having this particular relationship, then it will be able, if it will be tough to maintain, tough to maintain. Then if there are certain addition of rows or columns, then sparse data is more in rdbms. But once we are having NoSQL data, we are having different dimension, and based upon those particular dimensions, we will be able to minimize the sparse data. Sparse, that is blank records, okay. So multiple differences are there, once we are having NoSQL databases, and these are in order to uh, you can say uh, handle huge amount of data. In the databases, we need to keep the data in table format, tabular format. But over here, we will be able to access with the help of file name only, right? Fine.
Fine,
Multiple
Ashok, fine.
multiple differences are there, and we will be
Hmm.
going in detail. We will be starting HBase. We will be going in detail with HBase. We will be having HBase command and all. Okay, at that moment we will be going through with the differences and all, so at this moment just try to focus on to two words, say databases are acid compliant. Okay, we are having four properties, uh, that is atomicity, consistency, isolation, and durability, let me mention for you, just a minute, so SQL database and NoSQL database, okay. So SQL database, uh, ACID compliant, and no ACID compliant. So let me give you the feel of one word. Say consistency. ACID, that is atomicity, consistency, isolation, and durability. These are the four words, which is the definition of acid. So say consistency, like say I'm having certain record, I'm having one bank account, and at say uh, 10 a.m. 10 a.m. Uh, uh, the balance is there, say 10K, okay. Then at 10 I have withdrawal, say 5K, okay. And then So 10K, yeah. Person one, say bank side. I'm just giving an example what exactly the meaning of consistency. Yeah. So 10 a.m. 10K is there, then 10:10 withdrawal is there, and at say 10:06. Okay, if like the balance is still maintained 10K over here. Okay, that means like there is no consistency inside the database. Okay, whatever the transaction is being done on a particular database, okay, it must reflect on all side, either it is from my side or towards the bank side. You can take it in this way, like I'm having two debit card, okay, and the balance is 10K only, and like I have given one card to my wife, like I'm taking an example of joint account. Okay, so two debit cards are there, and my wife has done the withdrawal of 5K at 10:10, and at say 10:16, sorry, 6. At 10:06, I am going to, I'm in another city and checking the balance, and it is still 10K. Okay, the withdrawal has done, but it is not reflected in the bank side. It is still showing 10K. That means it is not having consistency. The transactions are not having consistency. So the consistency, the definition of consistency over here, like if a transaction is reflecting in complete at all the end, if a transaction is reflecting complete at all the end, that means it means we are having a consistent transaction. Okay, so that is the meaning of consistency. Yeah. So databases like the SQL DB are having consistency, but inside the ACID compliant or no SQL DB, okay, we are not having consistency. Yeah. Okay, isolation, like say if we are having certain halt in the services, or if it might be possible certain network fluctuation is there, then it is not like say the status is not maintained. Okay, so there must be some locking mechanism, say if two persons are working, okay, and they are not interacting with each other, but the end outcome will be the same only. So that is isolation. Atomicity, like each and everything must be reflected same towards all side. Okay, like if say a particular transaction is failing, okay, so it must be reverted in time. Sometimes like what we are able to see previously, like we have done the withdrawal of 5K, then money is not deducted, money is deducted, but we are not able to get the money. Okay, so account has been deducted, but we are not getting the money, and after some time what we are able to see at that moment only, like we got the SMS that the like uh, 5K or whatever the amount that you have done withdrawal, the transaction was showing successful earlier, but it was failed in real, so that particular amount has been credited in your account. So those particular things are nothing but atomicity. Yeah. So databases, what we are having this particular world, those are having ACID compliant. Now, once we are dealing with SQL DB, then there are the things like if we need to add record, then it is very tough. If we are uh, going to add some record, you can take in this. I'm taking an example. Say we are having employee id, name, and say salary, and say designation. Okay, this is the schema for this particular data. This is the schema. Say we need to add another column. Say job role. Job role. Okay. So job role. If we need to add another column, so it will be reflected to all. It will be reflected to all. But what is happening inside the inside the NoSQL databases, we are going to maintain the data in this particular way. Say employee ID. These are the columnar store. Employee ID and say name, say salary and designation and say job role. So employee ID 1. Employee ID 1 job role is there, but for employee ID 2 I don't want to have job role. I just want to have these particular fields only. For employee ID 3, say I don't want to provide to have the salary related information. So the data will be maintained in columnar way, columnar fashion. So over here, if we are having 1, 2, and 3, for say this particular person, the job role is there. For the employee ID 2, this will be the blank record. Job role will not be there. For the employee ID 3, the salary information will not be there. So these empty records are known as sparse records, sparse data basically. Once we are having sparse data, that means like a lot of empty records are there. I'm taking a very small example, simple example. Three records are there, but with respect to the three records, two fields are not there. This is nothing but sparse data. So SQL databases are having sparse data, but over here we are maintaining the data in the columnar fashion, and the sparse data has been removed. There is no sparse data, right? So that is the beauty of NoSQL databases. Okay, so I'm taking I have taken two examples only, but there are a lot of examples, differences. We will be discussing in detail. Probably it it will provide you certain hint like how the NoSQL databases are working and the benefit of NoSQL databases. Right, right, Gaurav? I think Gaurav was asking.
Yes,
Fine so
yes,
far?
yes, yes. Yeah, fine, fine, fine.
Okay. So this is just an example from the different side. What is the difference between SQL databases and NoSQL databases? Okay, over here we are having the data in tabular format, but inside the HDFS we are going to keep the data in file in terms of files. We will be slowly we will be moving. Okay, and then you will be having the clarity, like why we need to put HBase over there, why we have not kept SQL database. The another difference, SQL databases are working on monolithic fashion. Okay, but if we are having multiple machines, then SQL databases will not be able to work, right? So we need to have the database which is having the benefit to work in a distributed fashion. If the data is stored into multiple machines, we need to have a database that will be able to fetch the data from different machines and will be able to process that particular data. So we need to have NoSQL databases. SQL databases are not meant for distributed world, right? Fine so far?
Fine, Ashok.
Okay, perfect. Command. Anybody? Linux commands. So the basic Linux basic file and directories command. Let me mention the categories. Basic files and directories command. commands. Then we will be having system information related command, commands, user management commands. Then we will be having networking commands. Then we will be having file compression and package management. Package management. So although like a lot of things are there inside Linux, and we are having a lot of commands, but we will be moving with the commands which are required with respect to our job profile. We will be having certain persons like Linux admin or system admin who are having uh, like a detailed list of these particular command, but we will be moving with the commands which are required with respect to our job profile. We are not moving with the system admin related stuff. We will be moving with the role that is big data developer or big data solution architect. So from that particular role perspective, whatever the command that is required, we are going to learn now. So the first one is basic file and directory related command. The first one is basic file and files and directory related command. So once you are inside your Cloudera quick start VM, okay, then you will be able to see this particular symbol that is nothing but the terminal. You just need to click onto the terminal, and your Cloudera quick start VM terminal will open up. Over here you can change the profiles and all, profile preference, like if you want to change the background compatibility, colors and all, based upon your look and feel, like say if you want black screen or the font color different, if you want to increase the font size, so you can change the configuration from here. Okay, so the very first command that we are having in order to list the file, that is ls. Ls. So ls is the command in order to list the files and directories. Ls command to list the file and directories. Ls command to list the files and directories what we are having in uh, in terminal. In terminal present working directory. So inside the home oblique Cloudera, whatever is available inside this particular present working directory, ls command is going to list for you. Okay, pwd, that is nothing but present working directory. Pwd provide you the information about present working directory. Okay, present working directory. Now what you are able to see over here, we are having certain like files are there in black font. Some of the files are there in green font, green color font, and some of files are there in blue. So what we are able to see over here, black, blue and green color, font color. So font color black, that is denoting files. It is denoting files. Blue color is denoting directories. Directories, and green color is denoting executable files. Executable files. Okay, so these are directories, desktop, document, downloads. These are the executable files, Kerberos, parcels. Okay, and blue, that is directory, and these are nothing but files, like our transaction.java. Okay, employees dot out, hello. Okay, these are nothing but files what we are able to see over here inside the pwd. That is nothing but the present working directory. So if we want to see the files from the different path, say I just want to check what is available on desktop, so what I need to do, ls, and then uh, desktop. Okay. Okay. So ls desktop. So onto the desktop, what we are having, these particular files. Okay. Say you can change the directory as well. Say cd desktop. Okay. And now the directory has been changed, and you can run this particular ls command. So you will be able to get the files. Control shift plus plus. I think screen has been hanged up. Screen was hanged up. Control shift plus plus. Okay, clear, in order to clear the screen. So what I have mentioned, say if you want to go on a particular path. Okay, so what you need to do, you just need to mention the path of that particular file. Say onto the desktop. Just have a look onto the desktop. uh, Let me close this. It is not responding. So on desktop we are having test, and test is having base 26. Okay, so I just want to check what is there inside the base 26. So what is the path for this? The path for this is this one. Okay, so home, Cloudera desktop. So why we were not able to get ls and desktop? So ls desktop, we have executed this particular command, but it is saying, say, no such file or directory is found. But it is what is the pwd over here? This is the pwd. So over here inside the pwd, it is checking the desktop. So desktop, so the spelling is wrong. Desktop. Okay. Okay, so over here inside the pwd, it is checking for the desktop, and it is not able to get. So what is the absolute path? Say over here, say this is the absolute path. Say ls, and I'm just mentioning the complete path. Okay, home, Cloudera, a desktop test. So I'm able to get the information about this particular file. If I just want to have the information about a desktop, so this is the absolute path, home, Cloudera, desktop, and it is going to list the files which are available onto the desktop. Blue one directory, green one executable, and black one, these are the files. So what I have mentioned over here, I have mentioned the absolute path, and with the help of absolute path, you will be able to get the information wherever you are existing. So if let me take an example. So the present working directory is this one, a home Cloudera. Okay, home Cloudera. This is my present working directory, and inside the from the home Cloudera, if I'm going to list, it is going to provide me the information about the present working directory. Okay, but say I'm inside the document, say cd documents. I'm inside the documents, and inside documents we are having these particular files. But is it possible that from document itself I will be able to list the files inside which are available inside this particular present working directory? So I just need to mention the absolute path, and then I will be able to list the files. So this is the absolute path, and let me mention it over here. ls that is fine now. So it is going to list the files which are available inside the test-txt best 26 and test-txt best 26. So ls command and mentioning with the absolute path, what I will be able to get, I will be able to get the information about all the files and directory which is available in this particular path. This is the absolute path. And if I'm mentioning ls over here, this is providing me the information about, like say over here, if I'm in this particular directory document, let me mention the pwd over here. The present working directory is this one, but I'm able to get the information about the css image, because I'm inside this particular directory. That's why I'm able to get the information about this particular file. But if I'm out from this particular directory, with the help of ls command, I will not be able to get the information. So that is nothing but the relative path. Let me mention over here, relative path and absolute path. Relative path, that is incomplete path. Okay, incomplete path, not recommended as well, recommended. Or absolute path, that is the complete path, complete path and recommended. Okay, why it is not why the relative path is not recommended? Say over here, like having this particular file now, I'm having css, cd css, okay, ls. So at this moment I'm getting the information about css directory. Let me come out from this and say cd document. Okay, so if I'm mentioning, say ls and say css, ls css, okay, ls, okay, so ls css, so it is going to list me the files inside the css directory. ls css, just have a look over here. ls, it is having css and img2 files, and ls inside the CSS, inside CSS, huh. CSS, huh. Inside CSS, we are having Bootstrap and CMS, two files. At this moment, ls CSS is that is working. CSS is a directory inside the document. But uh, but PWD. So PWD is this one. If I'm coming out from document, then ls CSS directory will not work. Say I'm over here, and if I'm mentioning ls CSS, it will not work. No such file or directory, because the path is not complete. If you are in the directory where the file is located, then you will be able to run the ls command over there. But if you are out, you are not in that particular directory where you are firing that particular command, then you will be getting the error. That's why we are getting the error over here, no such file or directory, because the path is not complete. This is the incomplete path. So it is recommended that you need to have the complete path, that is absolute path, and you can run it from anywhere. Uh, you might be available in any directory, but if you are having the complete path, absolute path, you will be able to run it from there. Say I'm inside the document. Let me give you one example document, and say cd css. Okay, I'm inside the CSS. Okay, and now what I just want to check what is available in bash 26. So what I just need to mention, I just need to have the absolute path of this. Okay, copy, and over here as well, I will be able to get the information. Say bash 26 is having this much information. So bash 26, say test bash 26, and we are having bash 26. Inside the bash 26 we are having, so inside the test we are having big log txt, that is fine. We are having test bash 26, that is a directory, that is a the directory, and test.txt, that is a file. So we are having these particular files. Hello and hello, this particular file, this is the temporary file. It is not there, but this is temporary file. During the command execution it has been created. It is not making sense to us. So what I mentioned, like, we need to follow the absolute path whenever we are working with Linux. So two commands we have covered, ls and pwd. So ls, in order to list the directories, files and directories, and pwd, that will give you the information about the present working directory. Now we are having multiple flavors of ls command. ls command flavors. Say ls hyphen a, it will going to list you the hidden files as well. List the hidden files. Okay, just have a look. Let me clear the screen and let me come on to the present working directory. Ls, okay, clear. So I'm here only present working directory, that is home cloud era. Now what I just want to get the information about the hidden file. Okay, so ls hyphen a. Okay, so previously the files with dot were not visible. Just have a look. Dot, vbo, excellent, vimeo, vi info, vim info. Okay, what we are having, dot bash 21, dot bash rc, dot gtk bookmarks. So previously these particular files were not available. So ls-a is going to list you the hidden files and directories. Directories. Then we are having if we want to files, if we want to see the files and directories with respect to the modified data, ls-t, list files and directories with modified data. Not hidden. Okay. Okay, so ls hyphen l hyphen t, so ls hyphen t, we are not able to see the information over here, like is it modified or not. So in order to get it, what we want to have more details. ls hyphen lt, that is ls hyphen lt hyphen l. We want to list it with more details. Although like we are able to get the modified information, but we are not able to consume it. So ls hyphen t hyphen l hyphen l. Okay, just have a look. Now we are able to see it with respect to the modification. So this is say modified at 2017, and over here like downloads, today itself we have modified the downloads. Okay, so it is no, not today only, like in December it was say modified. Okay, so what we are able to see over here, ls-t, it is going to list the files with respect to the time, and ls-l, it is going to provide you more details. Okay, so list the files and directories with modified date. Okay, and list the files and directories with modified date with more detail, more detail, details. Okay, if you want to find out these particular details in reverse order,
Ashok,
reverse,
can we use ls space hyphen lrt as well?
yes, we can use lrt.
Okay.
Okay, I am just giving you like the insight of each and every command. LRT is being used. Majorly LRT we are like in my current company say, okay, ls hyphen LRT is being used by developers. Okay,
Okay.
so ls hyphen l hyphen say ls hyphen say t hyphen L hyphen R. What I mentioned, it is going to list in reverse order. 2017 is at bottom, and now 2017 is at top. Okay, and we are having the modified, like recently modified at the bottom at this moment. ls hyphen LRT. Okay, so that is also giving me the same information, right? Okay, Pankaj.
Okay, sure.
Okay, say ls
Yeah.
hyphen t. Okay, it is giving me in reverse order, and if I'm mentioning lrt, it is giving me in reverse order. R for reverse. Okay,
Okay.
perfect. So ls hyphen lrt. So it will depends on you, like how you are going to use ls hyphen hidden, ls hyphen t lr. You can, or lrt you can use in one go. That is say ls hyphen lrt. So it is going to list the same output. Both of these two commands are similar. Okay, Now moving further, like if you want to have the outcome in recursive order, like if you want to get the outcome recursively, say what is the meaning of recursively? Say desktop, desktop is having say 4 files, so recursively it will first display desktop, and then what is there inside the desktop, each and every file will be listed with the help of mentioning the data, this particular command in recursive order. Just have a look, so it is going to list each and every file, so from this particular path, the present path, it is going to list say total 8, in this particular path these are the 2 jar files, and I just want to list say over here total 32, on this particular configuration we are having say 32 files, on this particular path we are having 100 files, so it is going to list each and everything what is available in a particular folder, that is going to list you uh, the files and directories recursively. Say download, inside the download it is showing say total 0, we can validate, so downloads, so mhm, what I can, okay, download is having nothing, and that's what was mentioned inside the download total 0, okay, and say, so like whatever is available in a particular uh, path, okay, it is going to list each and every file recursively, like what is the count and all, okay, so recursively is going to list you the files, I think we can conclude for the day. We have covered a lot, so and it is almost 2.5 hours. Okay, so let me try to conclude what we have covered. So today we have gone through with like the different modes which are available inside the Hadoop ecosystem. Okay, we have gone through with 3 modes: standalone, pseudo distributed, and fully distributed mode. Then we have seen certain configuration files, and inside the configuration file what we have observed, or if we want to conclude like why we need to have the configuration file, so that is like once we are working with Hadoop ecosystem, then how a particular tool is interacting with Hadoop ecosystem, so those particular configuration we need to have, and there are certain basic configuration which are required in order to uh, have the basic functionality inside the Hadoop, like how the MapReduce will work, how the SDFS will work, where we will be having node manager and resource manager related stuff, what will be the port of resource manager, what will be the port of node manager, those particular configurations, say replication factor, cluster ID, okay, storage, so temporary path and all, those particular details are mentioned inside the configuration files, and we need to have the basic understanding, and that is not required in detail, but we need to have the basic understanding. Moving further, we have seen like the differences about the simple small differences between the SQL DB and NoSQL databases, and what we have observed, like SQL DB are having the sparse data, those are having say blank records, and SQL DB is ACID compliant, and NoSQL DB that is having the benefit like it is able to handle sparse data. We will be having small, we will not be having the sparse records over there, and like it is good, based it is good, and it is good if we are comparing it with NoSQL databases. And in order to work with the distributed mechanism, we need to have distributed, or you can say NoSQL databases. Okay, there are other functionalities as well. What we are having inside the NoSQL databases. Say some databases are memory optimized, memory optimized NoSQL databases. Some databases are there which are like key value databases. Some of the databases which are dealing with say dealing with hierarchical data, what we call graph databases. Although these are the flavors of NoSQL databases, but based upon the data, the type of data what we are having, or based upon our requirement, we are going to opt a particular database. This is the job of us in order to identify a good database. uh, it might be SQL or NoSQL, based upon the flavor of data. Okay, so NoSQL databases are having different flavors, and based upon the need, we need to opt a particular database. We will be having one theorem which is going to differentiate NoSQL data as well. That is CAP theorem. So CAP theorem is going to provide the difference between SQL, NoSQL databases. Okay, and from NoSQL itself, like which we want. Okay, so we will be going in detail, but these are the basic differences. Then we have started like Linux command, and we will be having multiple flavors or categories of Linux command. And we have started the very first category, that is basic file and directories command, and we have gone through with three commands only. Yeah, that is ls, pwd, and pwd. So two commands. So ls and pwd, we have covered two commands only. Okay, and we are and in the next session we will be going in detail about the Linux command, the different categories of Linux command, and then we will be going to start the Hadoop commands. Okay, that's it for this particular session, friends. If you are having any doubt, you can ask. Let me stop recording.